Right, this is the key for section 7. Alright, we start off with number 1. This is from topic 8. In triangle DEF, M is the centroid. So centroid is where all the medians meet. Also, what you need to know is that this centroid will cut this piece at one of the thirds. So if I cut this whole piece into a third, here's one of the thirds. This part we can cut it in half. And there's your 3. So when I look at this first one, if I want MK and DK, okay, MK is here, and DK is the entire length. I know that DM is 8, so from D to M is 8, and that's cut in 2, so I can just take half 8 is 4. This is 4, which means this last piece will also be 4. Alright, so if I look at this, what is DK? What is MK? Alright, so M to K is just that short piece there, that's 4. DK is the entire piece, that's 4 plus 4 plus 4. It's 12. Next part's a little bit more tricky. JM. Alright, so from J to M is here. And FJ is the entire piece. Okay, so in order to do this, we gotta look at the equations they give us. So MJ or JM is this part right here. Remember, we can also cut the longer piece in half. So there'll be 2 parts there. Alright, so if I know JM is 2x plus 4, and I know F to M is 5x. Okay. So I know I can go ahead and start off with setting them equal, and then I'm going to have to do something to the equation. So 5x is equal to 2x plus 4. Again, this part, these 2 parts are not equal to the 1 part. So think about that. If each part is equal, you know 2 parts, the 5x is 2 parts. I need 2 parts to be on the other side. Well, this is just 1 part. So if I double JM, that would give me 2 parts. So 2 parts equal to 2 parts. Again, we had to double this one equation in order to equal to these 2 parts. From there we solve. Distribute and solve. Get all your letters on one side. Subtract 4x. Subtract 4x. X is equal to 8. And then I need to find JM and FJ. Okay, so once you have 8, you are going to have to plug that back in order to actually find JM and FJ. Alright, so JM or MJ is this piece here. It is represented by 2x plus 4, so we're going to replace the x with 8. Alright, so JM or MJ, you'll do 2 times your 8 plus 4, which would be 16 plus 4 is 20. FJ, by looking at this, alright, so JM in here, it was 20. So 1 part's 20, this part would be 20, this part would be 20. Okay, so FJ, the whole part would be 20 plus 20 plus 20, and that's 60. Okay? Probably the hardest question on the whole review is number 1, so hang in there. Getting easier. Number 2, can a triangle have sides with the given lengths? Okay, so what you have to remember is you take the smallest 2 sides, add them together. They have to be greater than the 3rd side. Okay, so on this first part, the smallest 2 sides are 7 and 7. So 7 plus 7, it has to be greater than 14. This is the deal though, 7 plus 7 is 14. 14 is not greater than 14, so this would be no. Check out the second part, 10, 11, and 20. So again, 10 plus 11 has to be greater than 20. Well, 10 plus 11 is 21. 21 is greater than 20, so yes, gotta make a triangle. Alright, and then the last one, smallest 2 radicals, still gotta add those. Square root of 4 plus the square root of 8 has to be greater than square root of 22. Okay, well, you can use a calculator for this. I mean, square root of 4 is just 2, but I was going to do this here. We've got the second square root, in case you forgot how to put that in. Square root of 4. Scroll out, plus the square root of 8. Scroll out, let's see what that is. All right, definitely not a decimal in this calculator. So, oops. I'm just going to push the little arrows. Hold on. Push the arrows down here. That'll get you a decimal. And that's that. All right, so those added together is 4.828, yada, yada, yada. I'm going to compare that with the square root of 22. And again, I just going to make that a decimal with these little arrows. All right, 4.69. So yeah, that is greater. The two sides are greater than the largest side, which means yes, the third one is also a triangle. All right, so number 3, the measures of two sides of a triangle are 18 and 33 feet, and the measure of the third side is x. Oh, sorry, if the measure of the third side is x, find the range of the value of x. All right, so quick trick. Essentially, all you need to do is you need to add 18 to 33 to figure out one number, and you need to subtract 33 minus 18 to get the other number, and there's your range. So 18 plus 33 is 51. And 33 minus 18 is 15. So that means x has got to be between 15 and 51. So if you come over here, always put your smallest number. I mean, this is x is greater than this number. It's got to be between, rather. These two numbers, we got to do 15 here and 51 here. Do not put 18 and 33 in here. You'll get that wrong. Number 4. Following sides make up triangle ABC. List the angles from smallest to largest. Drag the correct description, yada, yada, yada. Okay, best thing to do. Draw the triangle. Here's my triangle. Doesn't matter how you put ABC. Okay, they say AB. Okay, so AB, if it's two letters, that's a side. So A to B is 5. B to C is 12. And C to A is 13. All right, so if I want to list the angles from smallest to largest, remember the angles and the sides are they relate to each other directly across from each other. So think about this. The smallest side here, smallest side is 5. So across from 5 is the smallest angle. The C is your smallest angle. Smallest. All right, so the next smallest number would be 12. All right, so 12 is the next smallest number, and across from 12 is angle A. So A would be your middle. All right, and then last one, your largest side would be 13, so across 13 is B. Okay, so there you go, largest. Moving on. In the diagram below, perimeter of triangle ABC is 748. So from A to B to C, whole triangle, the perimeter is 748. Answer the following question. So a few things I see. Y is a midpoint of BC because they have 3 ticks here and 3 ticks here. Z is also a midpoint, and X is also a midpoint. We connect midpoints, we make mid-segments. Okay, so they give me the perimeter of the whole triangle at 748. So you can do this one of two ways. In the mid-segments, like I know if I double the mid-segment, so if I take 2 times the mid-segment, that equals a perimeter. That equals the whole side. Okay, so one way I could go about this is I could double all the mid-segments and said then equal to 748. Could do that, or they give you the whole triangle perimeter of 748, I could take half of this, half of that, and set that equal to the mid-segments. I don't care which way you roll. I just always like to just go ahead and double the mid-segments because that's how my brain works. So I'm going to add all my mid-segments up. That would be the perimeter of this small triangle. So I'm going to go 3x minus 2 plus 2x plus 15 plus x plus 7. And I'm going to double that whole thing because it's all the mid-segments set it equal to the perimeter of the big triangle, 748. I'm going to solve, right? Combine all my like terms. So 3x plus 2x plus x is 6x. Negative 2 plus 15 plus 7. Well, those are 22. Minus 2 is 20. And I'm still doubling all this. So set equal to 748. You could do one of two ways. I could distribute 2 and solve. I could go ahead and divide by 2 in the beginning. 6x plus 20 is equal to what? 748 divided by 2. 374. Subtract 20, get my numbers on one side. So I've got 6x is equal to 354. And then last step, divide by 6. And 354 divided by 6 is 59. Cool. So when I look up here, I got x. X is 59. Great. If I want AC, okay, AC is this whole distance here. I know the mid-segment to AC is xy. Again, if you double the mid-segment, is equal to the side. So the mid-segment, you know, is 3x minus 2. And you know what x is. So let's just plug in xy. Plug in 59 for x. Let's see what we get. So 3 times 59 minus 2. 175. So I know the mid-segment is 175. If I double the mid-segment, I get the side. So if I double 175, I get the side. Double 175, and that would be 350 for AC. AC is 350. Alright, the thing is 350. Okay, then I need to find BX as well. Okay, so BX is from here to here. Note that's not the entire side. Again, this side would be related to the mid-segment over here. Well, we know the mid-segment is 2x plus 15. So again, you can go ahead and plug in your x for 2x plus 15. So again, so you've got y, z, 2 times your x, which is 59, plus 15. Alright, so 2 times 59 plus 15 is 133. Question is, okay, so this part's 133, how does it relate to BX? Well, they're going to be congruent. The same thing. It didn't ask for BA. If they asked for BA, then you would have doubled 133. But it's just half of BA. It's just half, which will be the same as the mid-segment. So your answer here is 133. Done. Alright, 6. Find the angles that make up ABC. You gotta measure A, B, and C. So you can draw a picture. It's the best way to go about this. Okay, so measure angle A, B, C. A is 143. B is 17. And C is 20. Okay, so I was gonna do this problem. And they want you to drag and drop for the sides of the triangle. Again, the angles and sides are related. So if they want so for instance, the shortest side, which one of these sides is the shortest, you're going to find the smallest angle first. So smallest angle, 17. Across from that is the shortest side. So AC would be your shortest. Alright, middle. So the next smallest number would be 20. So across from 20 would be the middle. AB? Right here. And then process of elimination. Obviously, your largest angle is 143. So across from that is your largest side. So that'd be BC. Or longest, rather. Sorry. Number 8. Or 7, rather. The following diagram has the medians. There's that word medians again. Where all the centroids meet. Of K, L, J. No, is shown. Okay, so of KG. So we find KG is here. KG is 84.3. Find the value of CG. So they only really want this part. Okay, well, remember that. This right here is your centroid on the median. Okay. Remember, like, this is your one part. Over here, you can cut in half. So there's 2 parts there. Well, they say the whole thing, KG, is 84.3. So they give you the whole thing. Let's just take 84.3 and divide it by 3 parts. Okay, 84.3 divided by 3 is 28.1. So that means each one of these is 28.1. What's the value of CG? Okay, so CG, boom, it's 28.1. Done. Right. The vertices of ABC are yada yada yada. What type of triangle is ABC? Okay. Okay. I need some graph paper for this one. Let's see here. Alright. Un momento. Alright, so I got some graph paper. Alright. And I'm going to go ahead and graph this. So let's do something like this. Alright, so A is at -1, +3. B is at 5, 5, 5, 5. And C is at 4, -2, 4, -2. And then if I want to go ahead and make this triangle, we'll just make it nice and pretty. Okay, looking at what we have here. A right triangle. Just off the bat, it doesn't look like any of these angles are right or 90 degrees. Isosceles, maybe. We got to have 2 sides that's congruent. Equilateral, all sides have to be congruent. I don't think it would be that one, but we don't know. Scaling, all sides are different. Okay, so I'm going to start off with doing one that maybe I think it will be. If I was looking at this, I think it's going to be either an isosceles or equilateral. Okay, if I had to guess, it looks like this side is congruent to this side. Really is what it looks like. So just to double check, you can use a distance formula. All right, we know distance formula or Pythagorean theorem. So Pythagorean theorem is what I'm going to roll with. That's when we just make right triangles off each side. So if I do this, right, your A and your B are the 2 perpendicular sides. C is what we're actually trying to figure out. That'd be the length from C to B. So if this is 1, this is 1, 2, 3, 4, 5, 6, 7. Plug that in Pythagorean theorem. 1 squared plus 7 squared is equal to C squared. And then solve. So that's 1 plus 49 is equal to C squared. Take the square root. Okay, so C is equal to square root of 50. I'm just going to leave it like that. No need to get to decimal, so from B to C is square root of 50. Okay. So again, I just looking at this eyeball, it looks like this side is congruent to this side, so I'm going to check that. Same thing, right triangle. Okay, so we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Plugging in Pythagorean theorem again. 5 squared plus 5 squared equal to C squared, where this is your C. Alright, that's 25 plus 25 to go to C squared, and that's 50. Square root, square root. Okay, so this side is also square root of 50. Cool. So I know it's at least an isosceles. I want to double check to make sure it's not an equilateral, meaning all sides are congruent. Then I need to do Pythagorean theorem one more time. Alright. So, like I said, it's definitely an isosceles. At least can't be scaling. We've got two sides the same. We're checking to see if it's equilateral. I'm guessing it's not right. So let's check this out. Alright, we got 2. 1, 2, 3, 4, 5, 6. Plug in Pythagorean theorems. 2 squared plus 6 squared equal to c squared. That's 4 plus 36 is equal to c squared. Alright, that gives me 40. Take the square root. Okay, so the square root of 40 is equal to c. That's definitely not square root of 50, meaning we definitely have an isosceles triangle. So B is my answer. Number 9. Triangle ABC is shown below. Find the radius of the circumscribed circle. Okay, circumscribed just means that there is a circle that is scribed around the triangle. Alright, very nice. That's very nice. ABC. There's your triangle. You want the radius. Remember, a radius is just from the center of the circle to a point on the edge. Well, that's fantastic because they give you 2 radii. Well, and each of those radii are represented by an equation. So all you need to do is set those equal because all radii are congruent. 8x minus 2 is equal to 2x plus 16. I'm going to get all my letters on one side, so I'm going to move 2x to this side, subtract 2x. Now I'm going to get all my numbers to this side, add 2. Divide by 6. Alright, cool. That is not the answer, people. Make sure you go back and check the question. You want the radius. So the radius is either of these guys. Just plug it into one. And we're going to do it both, just to double check. So if I plug into 2x plus 16 2 times my 3, which is my x, plus 16, I get 6 plus 16, which ends up being 22. There's your radius. If you want to double check, you should get the same thing with this one. 8 times 3 minus 2. That's 24 minus 2, which is 22. Cool, same thing. Radius is 22. Alright, here we go. Okay, triangle ABC has the vertices, yada yada yada. Find the coordinates of the following points. The circumcenter of triangle ABC. Alright, here we go. Okay, so with these problems, with all these different vocabulary words, talked about this cute little way to remember these. It's this. The cyclist was eating peanut butter, and the ice skater had Applebee's. And they met at the center median where the orthodontist flew in his airplane to pick them up. What? Okay. So if you remember, the cyclist is where the perpendicular bisectors meet, and the cyclist is just fancy for the circumcenter. So here's your circumcenter. Is where your perpendicular bisectors meet. The ice skater is the incenter. That's where all the angle bisectors meet. And the center medians is where the centroid is where all the medians meet. And the orthodontist is where the orthocenter. The orthocenter, rather, is where all the altitudes meet. The airplane always deals with the height or the altitude. Okay, so having said that, rolling on. So this first one says find the coordinates of the following points. Find the circumcenter of ABC. Alright, so in this first thing up here, we're going to graph this. Alright, we got 1, 4, so 1, 4 is up here, that's A. You got -3, +4, that's B. and C is at 1, 1. Okay, oops, sorry guys. Alright, so if I want these circumcenters where all the perpendicular bisectors meet, so we have to know perpendicular bisector. Bisector means cut in half, and perpendicular means 90 degrees. So if I look, so for instance, I get from A to B, cut this in half. Well, it's 1, 2, 3, 4 long. Half of 4 is 2, and perpendicular to this line would be this way. So that's one of the perpendicular bisectors. I also have to do it on AC. Well, AC, you've got 1, 2, 3, and half of 3 is 1.5. So up 1.5, perpendicular bisector. All right, where they all meet is where the circumcenter is. So my question is, what is this point? This is your x-axis, and this is your y. Well, if you note, that's -1. We go up 1, 2.5. So -1, 2.5. Again, that's where all the perpendicular bisectors meet. Okay. Next, they want the intersection of the altitudes of ABC. Okay, so just to keep this kind of a little bit neat, we're going to do this again. I'm going to graph it again. Okay, so we've got 1, 4, -3, 4, and 1, 1, C. Okay, so they want the intersection of the altitudes. Altitudes, again, think the airplane, that's where the orthodontist is finding his airplane. So that's the ortho center, again, where all the altitudes meet. So if you want that, the intersection of all the altitudes, think about each one of the sides has to be land. So like if I turn this is your land, here's your airplane, it drops straight down the ground. That is the altitude. So one altitude literally is this line here. Okay, if I do another altitude again, now I'm going to make this my land. Here's your airplane, it drops straight down. You only need 2, and the question is, where do they both meet? Well, they both meet at A. So the question is, what is the ortho center? Where do all the altitudes meet? It's right at A. So what is A? That is at 1, 4. And then I go to the next one. The endpoints of the mid-segment connecting AB and AC. List the point from smallest x coordinate first. Okay. Okay. Okay, so let's just, I'm going to use this one for the top, and the bottom one I'll draw one more time. Let me get a different color. Let's go pink. Okay, the mid-segment. So remember, mid-segment are half. It's basically a connection of the midpoints. So if I find AB, here's AB. Okay, and here's AC. I want the mid-segment of both AB and AC. I would find the midpoint of AB, which is right here. Midpoint of AC, which is half through, right there. Mid-segment connects those. So it says the endpoints of the mid-segment connecting AB and AC. List the point with the smallest x coordinate first. So we're talking about these 2 points here. So this point is going to have the smallest x coordinate because it's furthest left. It'd be at -1, 1, 2, 3, 4, +4. -1, +4. The other endpoint, all right, the x is a little bit larger here. It's at 1, 1, 2.5. 1, 2.5. Okay, so again, just so we can kind of see it, I'll graph it one more time. You can probably skip ahead if you need to. Alright, so A is at 1, 4. B is at -3, +4. And C was at 1, 1. So this next part, endpoints of the mid-segments connecting BC and AC. Okay. Alright, so again, you just need to find the midpoint of either side. I'm going to start off AC. That's a little easier. Half of 3 is 1.5. So there's one of your midpoints of the mid-segment. And then you also need the mid-segment or midpoint of BC. So I look at this. I'm just going to look. So from B, let's see. There's 4 boxes here. So over 2, midpoint's going to be right there. Again, so like what I did, I made like a right triangle here, and I just took half of each distance. So like half of 4 is 2, it goes right there. And this is 3 long, so half of 3 is 1.5, goes right there. So your midpoint would be right there. Thus, the mid segment is connecting these 2 pieces. I know this part's ridiculous. This is a ridiculous question. I didn't make it up, just for future reference. So, what are those points that we have connected there? I mean, and you have to list the smallest x coordinate first. So this first point's at -1, 1, 2.5. -1, positive 2.5. The other point is at 1, 1, 2.5. 1, 2.5. Okay. I know, silly question. All right, number 11. Use the information in the diagram to determine the height of the tree. This is your height, that's what we're trying to figure out. This diagram is not scale. Okay, so note things I know about this side. Right here's got to be a midpoint because you got a tick and a tick. Here's also got to be a midpoint. You got a double tick and a double tick, which makes the orange line or the height of the tree the mid-segment. Remember, we double the mid-segment to get the side. So they give you the side. The side is the building. That's the height of the building. So if I wanted the mid-segment, I just backtrack, right? If I have the height, I'm going to take 222. I'm going to divide it by 2. I'll get the mid-segment, 111 feet. Okay. All right, and that makes sense. If I double the mid-segment, so the height is actually 111. If I double 111, I get 222. 12. Find the value of x. And the value of the mid-segment. So, okay, so obviously if it's a mid-segment, this has got to be a mid-segment. It makes sense. This is 18 and 18, 23, 23. So again, here's your mid-segment, here's your side. Okay, so again, I know if I double the mid-segment, I equal the side. So even if you weren't sure, just go ahead and start off making them equal to each other and note that they're not technically equal. You got to use something. All right, so again, if I double the mid-segment, I equal the side. Double the short, equal the long. All right, which one is the short? It's the 4x plus 2. So I will double this guy. And then I'll solve. All right, so if I distribute it in, that's 8x plus 4 equal to 2x plus 16, and solve. I'm going to get all my letters to the side, so I'm going to subtract 2x. That's 6x. Get all my numbers to the side, subtract 4. 5 by 6. X equal to 2. Which is cool, but that's not all what they wanted. They want you to find the value of x and find the value of the mid-segment. Well, you got x, but the mid-segment is this piece here, so you got to make sure you can understand which one's the mid-segment. So if I want the mid-segment, I'm just replacing the x with 2 and solving. So that would be 8 plus 2 is 10. Mid-segment is 10. There we go. Done. All right, 13. Okay. Given triangle ABC is similar to triangle AD, and AD is 14. So from here to here is 14. What is the length of DC? All right, they want you to find DC here. They don't know what that is, so I'm going to put an X right there. Round the nearest 10th. Okay. So we have 2 similar triangles. I always like to redraw them right next to each other. It's just easier that way. So I'm just going to redraw this small one right here. Alright, there's a 12 here and a 14 here. I'm going to flip this bigger triangle right next to it. 17 is down below. This whole side would be 14 and x. So 14, and then there's the x. Okay, so then at that point, they're similar. We're using cross multiplication to solve this. So you got 14 over 12 is equal to this over this. Okay, so what does that look like? It's 14 and x, not 14 times x, 14 and x. So that'd be 14 plus x would go on top. On bottom would just be 17. Then we cross multiply and solve. So 14 times 17 equals 12 times 14 plus x. Don't forget parentheses. Alright, and then we roll. So 14 times 17 is, I don't remember, 238. And equal to, and distribute this if you'd like, 168. Plus 12 times x is 12x. Alright, and then we will subtract 168. Subtract that. That will give you 70 divided by 12. And 70 divided by 12 is a decimal, 5.8. They want the nearest tenth, so that would just be 5.8. 3 is not large enough to round you up. Boom. Alright, 14, solve for x. Well, look, so we have two similar triangles, which they did not tell you, but they should have. And they're similar. Then we can set up just like we did. So these and these. I'm just going to do this over here. So yeah, 7x over 12 is equal to 11 over x. Cross multiply and solve. Alright, so 7x times x is 7x squared equal to 11 times 12. And 11 times 12 is 132. Divide by 7 both sides. X squared is equal to 132 divided by 7 is a big old decimal. And then we're going to take the square root of that, right? So we took the square root of 132 divided by 7. So second square root. And these calculators, you can scroll up and get the exact answer. And so my final answer should be 4.34 if I want to go hundredths. Last one, 15. Alright, so 15. Choose the correct justifications to prove the two triangles below are similar. Okay, so remember, the only ways you can prove two triangles are similar are angle, angle, which would essentially be angle, angle, angle. Okay. Side, angle, side, and side, side, side. Okay, similar. And when you have sides, that means they're proportionate. So again, you have two triangles. I would redraw one of them to make it look just like the other one. So this one right here, I'm going to rotate around. I'm going to draw it right next to it. So I'm going to put the 90 degree right here. If I do the 90 here, I would want 16 degrees here, 74 degrees here. So if I look here, 16, that was C. 74 was B, right angle's A. Then I'm going to place my sides down. So A to C is 48. A to B is 36. And B to C is 60. Now I can look at this and all the sides are matching. Alright, so if I look at this, first one. Give you all these different ways of similarity and then not similar. Okay, so they say, okay, so the first one they say 36 over 12 is proportionate as 60 is to 20. Well, they did all their order right. So they started with the big triangle, small, big, small, and they do their correct size. The question is, are those actually proportionate? Let's check. So I do 36 divided by 12. Oops. It's 3. Is it the same as 60 divided by 20? Fantastic, yes. So that means these two sides are proportionate. And B and L, if you notice, B and L That'd be the angle between. So this side is proportionate to this side. You have an angle, and then this side is proportionate to this side. So according to line tag SAS, those are proportionate by SAS similarity. And that marker's getting through. Okay, so we roll on. All right, next one, looks like they have 3 sides. Let's just make sure that they chose the right size and the right order. So they did 60 over 20, okay, same side. 36, they started with the big one again, over 12, that's right. And then they started with the big one, 48 over 60. All is good. We already checked. We checked these two. Let's just double check that and make sure it works for this one. So what's 48 divided by 16? It is 3 still, so all is well. Similarity by SSS. All 3 sides are similar. Keep rolling. 48 over 20. So now we've got 48, which is down over here. 48 over 20. Ooh, that's already wrong. Those 2 sides are not the same side. So thus you can already tell me right now it's not similar. Okay, and just to really hit this home, they also have 16 over 60, so 16 over 60. Hypotenuse and a leg, no. All right, so they have to be right. They have to be paired correctly. Okay, next one, 36 over 12. Okay, so if I look at 36 over 12, 36 over 12, okay, so we're starting with the big one. We got this side over this side, which those are similar. 16 over 48. However, the next part, they did 16. They started with a small triangle over 48. Now, do they have right sides? Yes, but they switched the order, so the proportion will be incorrect. And what I mean by that is if you take 36 divided by 12, which we've done before, is 3, and I do 16 divided by 48, that is not equivalent. Those are different. They're not equal, so that is not similar.
I just finished it tomorrow. I know I'm basically done already.
Alright, so then next one, A and K are congruent. Okay, so just make sure they're in the right spot. They are. They're both the right triangle, or right angles rather. And C and L. So they have C is a 16-degree angle and L is a 74. Those are not the same angle, which means they are not similar. How to have 2 angles in the correct order. Alright, so looking at the last one, B and L. Okay, so finding B and L. Oh, good. They're both a 74-degree. And they also ask about, or say AK. Okay, A and K are both the right angles. So since you have 2 angles, that is all you need to prove 2 triangles are similar. So you would have checked that one right there for angle-angle similarity. And voila, there's section 7. Good luck, y'all.